Hi student, here I am discussing about resolution in stereochemistry. So what is resolution? The process of separation of enantiomers from a racemic mixture is called resolution. The process of separation of enantiomers from a racemic mixture is called resolution. So what is the need of resolution of racemic mixture? So I think you all are familiar with cetirizine. That means the medicine we normally use for the allergy. So cetirizine occurs as plus form and minus forms. But studies reveal that levocetirizine has been found to be less sedating than dextrocetirizine. So it is very essential to separate out the dextrocetirizine from the cetirizine compound. The next example is thalidomide. This example we have already discussed. That means thalidomide is a drug. In past, the thalidomide was given to pregnant women to lessen their morning sickness. In thalidomide also existing plus form and minus form, but plus form is only therapeutically active, minus form is therapeutically inactive, and also it makes some birth defects to newborn babies. So here also it is very essential to separate out the minus form of thalidomide from the thalidomide. The next example is levodopa or L-dopa. It's a drug used in the treatment of Parkinson's disease. Its D form causes serious side effects. So here also it is very essential to separate out the D form of the levodopa. So these are the method normally used to separate out the racemic mixture. That means first one is mechanical separation, preferential crystallization, biochemical separation, by diastereomers, precipitation method, chromatographic separation, kinetic method. So let us discuss one by one. First one is mechanical separation or spontaneous resolution. This involved mechanical separation of the crystal of one enantiomers from the other in racemic mixture based on the difference in the shape. Crystals of the two forms had different shape separated by using a magnifying lens and forceps. This method first used by Pasteur for the resolution of sodium ammonium tartrate, which crystallized out in the form of racemic mixture below 27 degrees. This method is time consuming and every compound cannot be crystallized at room temperature. This is the first separated crystals, sodium ammonium tartrate. This is separated on the basis of difference in the hemihedral phases on these two crystals. Scientific community believed that this was the most beautiful experiment in the history of chemistry. Second method is preferential crystallization by inoculation. This method involved seeding of a saturated solution of a racemic mixture with a pure crystal of one of the two enantiomers. The solution now becomes supersaturated with respect to the added enantiomers. It begins to crystallize out. The third one is biochemical separation. It was introduced by Pasteur in 1858. This method is based on the fact that when certain microorganisms like bacteria, fungi, yeast, mold, etc. are grown in dilute solution of racemic mixture, they eat up one enantiomer rapidly than other. Example, the mold Penicillium glaucum preferentially destroy the plus isomer of racemic ammonium tartrate, leaving ammonium tartrate in solution. So the main disadvantages of the method is it is very difficult to find out a proper microorganism which may consume one of the isomer in preference to other. And also by microorganism consuming only one type of enantiomers, so we got only one form. Other form is consumed by the microorganisms. The chromatographic separation. The racemic mixture can be separated by chromatography on an optically active support. The diastereomeric adsorbate, which are formed, have different stabilities. Thus, one enantiomers will be held more tightly than the other and would be eluted first. Next, this is a chromatography column. We filled first this chromatography column with a chiral or optically active compound. Then next, the racemic mixture is loaded onto the column. In the racemic mixture, sometimes one enantiomers will tightly adsorb on this stationary phase, and the enantiomers which have less affinity with the stationary phase come first from the column by a suitable eluent. The next one will come after the next only. Next one is kinetic method. This method is based on the fact that one of the enantiomers of racemic mixture react faster than other with optically active compound. For example, menthol react faster with plus mandelic acid than with minus mandelic acid. Thus, with the difference in kinetics of the reaction, racemic mixture can be separated. This one is precipitation. This method is based on the formation of precipitate by reaction between any reagent and racemic mixture. For example, plus and minus narcotin when dissolved in HCl, plus narcotin precipitate out first. So it can be separated easily. The last one is by diastereomers. When a racemic mixture is allowed to interact with optically active material, it gives a diastereomeric derivative. Diastereomers have different physical properties like melting point, boiling point, and hence can easily separated into two compounds by fractional crystallization. For example, here if racemic mixture of lactic acid when react with the brucine, L-brucine is a base, form a diastereomer D-lactic acid L-brucine and L-lactic acid L-brucine. This diastereomer can be separated, and this separated diastereomers on hydrolysis will give pure D-lactic acid. This diastereomer on hydrolysis give pure lactic acid. So these are the different methods used for the separation of racemic mixture: diastereomer, precipitation, kinetic method, chromatographic separation, biochemical separation, preferential crystallization by inoculation, and mechanical separation. So these are all about resolution.